Hey guys, these are questions we've gotten on 10.6 already, so here are um, my replies for that. So the first one was number 8, and it was solved for x here. And so what we have here is we have the secant. All right, so secant type problem. And if we remember, when we're dealing with secants, it's always, and you need to remember this, it's always the external part, right, times the whole thing. External times whole. So when we're doing this, you always have to keep it. It's external times whole. The inside part, the chord, only gets added to the external part to give us the whole thing. It never used in the calculation. So what I'm going to do here is I'm going to basically, we know the external part for each one is 4 and x minus 2 respectively, right? And what we're doing is we're going to multiply 4 by a number and we're going to multiply x minus 2 by something. All right. We see that 4 and 5. Well, we know the whole thing up here has to be 9. So it's going to be 4 times 9. And over here, it's x minus 2 plus x minus 4. X minus 2 plus x plus 4, which ends up being 2x plus 2. So over here, we're going to put 2x plus 2. All right. Now we've created our equation we can solve. So this is 36 equals, and then we just FOIL it from there. We get 2x squared plus 2x minus 4x minus 4. Simplify that. We get 36 equals 2x squared minus 2x minus 4. I'm going to move the 36 over to the right because I want it to equal 0. It's the only way I can solve for it. Minus 36. So we get 0 equals 2x squared minus 2x minus 40. And what I notice is they all have a 2 in, so I'm going to divide everything by 2. Makes it a little easier when I want to factor. So I get x squared minus x minus 20. And now I'm going to see if I can factor that. And that one actually factors very nicely to x minus 5 times x plus 4. Now I need to solve each of those for 0. So x minus 5 equals 0. And x plus 4 equals 0. So I end up with x equals 5 and negative 4. And the thing is, negative 4 is not going to work because if I plug it back in here for x up there, it's not going to give me an answer. It's going to give me a negative number. We can't have negative distances. So 5 is my answer. And we see that we get 3 on the outside, 9 in the middle or inside. And, that will work as well. Now, 3 times 12 does give you 36. The next question we got was 11. And this one is a secant times a tangent. And so if we remember, again, secant, this is a secant tangent one, is that when we're dealing with secants, again, it's the external part times the whole thing. And when we deal with tangents, it's always tangent squared. So if we start with the secant, it's the external part x times the whole thing, which is x plus 12. And then that is equal to my tangent squared. So x plus 4 squared. All right. So multiplying these out, I get x squared plus 12x equals, and if I FOIL that one out, I get x squared plus 8x plus 16. All right, I'm going to solve for x. And what I notice is I both have an x squared on both sides. So if I subtract both sides by x squared, they go away. So I'm left with 12x equals 8x plus 16. Subtract 8x from both sides. I have 4x equals 16. Whoops. And for some reason, it's not liking me as usual. So in this case, x equals 4. And we see that 4 and 12, and 4 plus 4 would be 8. So does 4 times, if you do the whole thing, would be 16. 4 times 16 is 64. 8 squared is 64. So 4 does work for our answer. All right, the next one was number 18. And it said us find PQ. So we are trying to find PQ here. and we want to round our answer to the nearest tenth. So we will require a calculator at this point. Again, we see here we have a secant and a tangent. Whoops, sorry about that. I don't know why it's doing that up there. We have a secant and tangent. So we want to find PQ, but first thing we need to find is QR. So I'm going to call that one Y. So again, we have a secant and a tangent here, or secant tangent. And again, secant is always external times the whole. So it's going to be 14 times the whole thing here would be 26. 26 equals, and we're doing a tangent, so in this case, y squared. So if we do 14 times 26, we end up with 364 equals y squared. So if we solve for y, we're going to take the square root of both sides. So y equals the square root of 364. Now, I'm not going to do anything with that yet because I need to wait till that. Then what we noticed is that based on the diagram, triangle PQR is a right triangle. Well, we have one side is 26. We have the other side is square root of 364. We can use Pythagorean theorem to solve for it. So I'm going to go x squared plus the square root of 364 squared, and this is why I didn't do any of the math behind it, equals 26 squared. So x squared plus 364 equals 26 squared, which is 676. So x squared equals 676 minus 364, which is 312. And we take the square root of both of that. So x equals the square root of 312. Whoops. Square root of 312. Which, since we're looking for the nearest tenth of that, we plug that in our calculator and we get 17.7. It's really 17.66, but nearest tenth, one decimal, gives me 17.7. And then 19. Now, this is the challenge one. It's going to require you to do a couple of different calculations and use multiple theorems / processes on this one. So it gives us that in the figure, AB is 12. It gives us BC is 8. It gives us DE here is 6. And it gives us PD here is 4. And it says A is a point of tangency. Find the radius of circle P. All right. Well, since AB is tangent to it, we now, if we look at it, AB all the way to E, that is a tangent and a secant. And we can find things with that. We know the relationship between that. So let's start with the secant tangent again. Secant tangent relationship, right? In terms of distances. So knowing that, I'm going to start with this. Let's start with the secant here. Remember, it's the external part times the whole thing. Now, the whole thing is 8 plus DC here, which we don't know. I'm going to call that X, and DE, which is 6. So our secant is going to be 8 times 8 plus X plus 6. And that's going to equal our tangent, 12 squared. So that's 8 and 14 plus X equals 144. And if I distribute 8 times 12, it's going to give me 112. 8 times 14, it's 112 plus 8X equals 144. Subtract 112 from that, and you end up with 32. So 8X equals 32, so X equals 4. So that tells me here that DC now, up there, is 4. All right, I'm going to redraw my circle here from what I need. So I got my circle. And we have that E here and C, and there's P. And what we had there was D. Whoops, sorry, it didn't come out very well. There's D. And what I'm going to do is I'm going to extend PD, and I'm going to make it a diameter right there. And I'm not really worried about everything else with that. But we know from P, let me use a different color here. We know from P that P to the edge here is R. We know that PD here is 4, and we don't know what the rest of this is. But we do know that if from P to the one side of the circle is R and P to D is 4, that if we extend P through D to the rest of it, that this missing piece here has to be 4, has to be R minus 4. Sorry about that. I was writing 4. It should be 4 R minus 4. And I know that's a little difficult to see, but again, if the whole thing is R and PD is 4, then the rest of it has to be whatever R is minus that 4. And we know that DC here is 4, and we know DE is 6. And if you remember from our theorems earlier, that this is a chord and chord, right? Two chords together, they intersect. So if you think about it with two chords, remember, it's the section, the multiplication of the sections of each chord multiplied together equal each other. So put it easily. Let's start with the EC chord. That would be 6 times 4 is equal to, and then we're going to do the diameter one, the one running through P. Well, one section of it from one edge through D is R plus 4, and then the rest of it is R minus 4. And that's going to look very nice when we actually multiply that out. All right, so here we go. This is how it's set up, and now we can solve for R. 6 times 4 is 24. And then if we FOIL this out, R, 4, negative 4, we end up with R squared plus 4R minus 4R minus 16. In all reality, that becomes 24 equals R squared minus 16. Oh, well, we can solve for that. R squared equals 40. Take the square root of both sides, and if we do this in simple form, square root of 40, that would be 2 root 10. Now, again, if you had to plug it in on your calculator or whatever, 2 seconds square root of 10, that would give you 6.32. I'm sorry, the drawings don't come out. I would have preferred this one if we could have managed it, the exact answer. Hopefully that answered your questions. If you have any more, please email me, let me know, post it on the thing, and hope to see you guys soon.